Hello dear students, welcome back. This is our 12th lesson for mensuration for O-levels and IGCSE exams. In today's class, we will solve some more questions from past year exams. Let us start our today's lesson. Question number 1. During a storm, raindrops fall into a cylinder which stands on a horizontal ground. The cylinder was empty before the storm started. The cylinder has radius 22 millimeter. Each raindrop is a sphere of radius 2 millimeter. After the storm, the depth of water in the cylinder is 16 millimeter. We have to calculate the number of raindrops that fell into the cylinder. Okay, first of all, we are given that volume of the water in the cylinder. We can calculate the volume of water because we are given the radius of the cylinder. Radius R is given by, this R is 20 millimeter, and height of the water or depth of the water in the cylinder is 16 millimeter. So what will be the volume of water? Volume of water will be, volume V will be base area of the cylinder multiplied by height, which will be pi into 20 square into height, which is 16. So this is volume of the water in the cylinder. This is a cylinder, its base, its radius is given, water is poured into the cylinder, and height of the water or depth of the water, this is 16. So I have calculated the volume of this water, which is this, pi into 20 square into 16. We can simplify it. It will be 6400 pi, which will be millimeter squares, a cube. This is volume of the water. So what is volume of one raindrop? Volume of one raindrop. Raindrop is a sphere and its volume is given by this formula, 4 by 3 multiplied by pi multiplied by r cube. R is 2 for raindrop. So this will be 32 by 3 pi. Now we have to calculate the number of raindrops in the cylinder. Number of raindrops will be volume of the water 6400 pi divided by volume of one raindrop, which is 332 by 3 pi. When you will simplify it, you will get your answer 600 raindrops. This was first question of today's class. Question number 2. We are given a diagram. It shows a square piece of card. This is a square piece of card from which a triangle and two small squares are cut. This is one square of length 1. This is another square of length 2. And this is a triangle. These three shapes are cut from a square piece of card. We have to calculate the shaded area. Shaded area is this area. How we will calculate this area? We will take the area of this square piece card, which is basically area of the card. What is side of this square piece? 5. So area of card will be 25 centimeter square. What will be area of this square? Area of small square is equal to 1 square 1. Area of large square is equal to 2 square, which is equal to 4. And area of triangle. Area of triangle. This area, okay, what is this side? This is 1. And what is this whole side? This is 5. So what will be this length? This length will be 4. Similarly, this length is 2, length of this square, and this whole side's length is 5. So what will be this length? This length will be 3. So area of triangle will be 4 into 3 over 2, 6 centimeter square. So area of 2 square is 1 and 4, and area of triangle is 6. So what will be the shaded area? Shaded area will be calculated by subtracting the 3 areas from the area of the card, which will be 14 centimeter square. In the second part of this question, we have to find the perimeter of shaded card. Perimeter will be this length plus this length, which is 2, plus this length, which is again 2, plus this length, which is 3, because this is 5 and this is 2, this is 2, so this will be 3. Similarly, this is 5, this is 1, this will be 4. This we calculated in last paper. This is 4, this is 3. So we will first use Pythagoras theorem to calculate this length. This length is 3 square plus 4 square square root 25 square root, which is 5. So this length is 5. Now we will add 5 plus 2 plus 2 plus 3 plus 4 plus 1 to get the perimeter of shaded card. 5 plus 2 plus 2 plus 3 plus 4 plus 1 plus 1. And hence we will get this is equal to 18 centimeter. Five plus 4, 9 plus 3, 12 plus 4, 16 plus 2, 18 centimeter. This was second part. Let us move to our third question. P and Q are points on the circumference of a circle. These are 2 points on the circumference of this circle. Circle has center O, it has radius R. Minor arc PQ is 20 centimeter. This is 20 centimeter. This central angle POQ is 48. In the first part, we have to show that R is equal to 23.9. Okay, we are given this arc length. We know that this arc length L is equal to 48 over 360 multiplied by 2 pi R radius. From here I will write 20 is equal to 48 over 360 into 2 into pi into R. From here R will be equal to 20 into 360 over 96 pi. When we will simplify this, we will get this is 23.8732, approximately equal to 23.9 centimeter as required. In the second part, we have to find the area of this minor sector. What we will carry from part 1? From part 1, we know that R is equal to 23.8732. This we will carry from part 1. And we have to find the area of this minor sector. What is formula for area of sector? This will be central angle over total angle of the circle multiplied by pi multiplied by R square, 28.8732 square. You will use your calculator to get your answer, which will be 238.73 centimeter square, approximately equal to 239 centimeter square. I hope this is clear. In third part, he says that the minor sector POQ, this sector POQ is removed from the circle and remaining major arc is shaped to form an open cone like this. This basically is an open cone with radius R. We have to find R. For that, this angle is 48. What will be this reflex angle? This reflex angle POQ will be equal to 360 minus 48, which will be 312. Now look at this. This circumference of the top of the cone is basically this length of major arc. Circumference is 2 pi r. 2 pi r is equal to length of this major arc is 312 over 360 into 2 into pi into r, which we calculated in the first part, 28.3.8732. From here we will find r is equal to 312 over 360 into 2 pi into 23.8732 divided by 2 pi. And when you will simplify it with the help of calculator, you will get this is equal to 20.7 centimeter, rounded off to near three significant figures. I hope this is clear. Now we are moving to the second part of this question. In the second part, we are given a cone which has a radius 7.5 centimeter and its height is 4 centimeter, and we have to find the curved surface area of the cone. Formula for curved surface area is given pi RL, where L is this slant height. Look at this. This is height, which is 4. This is radius, which is 7.5. Slant height will be calculated with the help of Pythagoras theorem, which is 4 square plus 7.5 square root. And this slant height will be 8.5 centimeter approximately. No, the curved surface area will be pi RL, pi into R into L, which is 8.5, and you will get this is equal to 200 centimeter square, rounded to three significant figures. In the second part, we are given that we have another cone which is geometrically similar to this cone, and area of cone, curved surface area, ratio of curved surface area to that of curved surface area of B is equal to 64 ratio 25, which we know from our concepts of similar figures. This is equal to 4, which is height of cone A, divided by height of cone B, its square. From here I can write 4 over h is equal to 8 over 5, which implies h is equal to 20 over 8, which will be 2.5 centimeter. This was second part of question number 3. Now we move to our next question. Question number 4. A container is made out of a thin material in the shape of cuboid with an open top. This top is open. The container has length 15, width 8, and its height is h. The volume of container is 720 centimeter cube. So we have to, in the first part, we have to find the height of the container. What is formula for height of cuboid? Length into width into height. This is volume, which is given 720. Length is 15, width is 8, height we have to find. This is 720. From here, height is 720 over 15 8s are 120, which is 6 centimeter. So this height is basically 6 centimeter. In the second part, we have to find the surface area of outside of the container. Please note that this height is 6. Okay, and this top is open. So this will not be included in the surface area. So surface area will be base area, which is length into width, plus area of front and back wall, which is 2 times 15 by 8, plus area of these side walls, which is 2 times 8 by 6. So this will be 15 by 8 base area, plus this is 15 by 6 actually. 2 times 15 by 6, 90, plus 2 times 8 by 6, 48. This is 120 plus 180 plus 96. This will be sum up to 3 96 centimeter square. I hope this is clear. In the third part, we are given that a liquid is poured into the container and it fills 60% of the container. This is the container. Liquid is poured into it and it fills 60% of the container. It means that height of this container, height of the liquid is equal to 60% of height of the container, which we can easily calculate. 60% of 6, 3.6 centimeter. I hope this is clear. Today's last question. OAB is sector of a circle. OAB is sector of a circle. It has center O, radius 10 centimeter, angle AOB is 72, and C is point on the arc AB such that OC bisects angle AOB. This angle is 36 degree and this angle is 36. We have to calculate the perimeter of sector AOB. Perimeter of this sector AOB. Perimeter will be this length 10 plus this length 10 plus arc length, this arc length, which will be 20 plus, what is formula for arc length? This central angle over 360 into 2 pi r, r is 10. So this will be 20 plus 4 pi, which will be 32.566 centimeter, rounded off to 32.6 centimeter. I hope this is clear. In the second part, we have to find area of sector AOB, this area, total area. What is formula for area of sector? Central angle over 72 over 360 into pi r square, r is 10. So this will be 1 by 5 into 100 pi, which will be 20 pi. With the help of calculator, we will write it as 62.83, approximately equal to 62.9 centimeter square. This is area of the sector. In next part, we have to find the shaded area. We just calculated the area of this whole sector. Area of sector was 62.83 centimeter square. How we will calculate this shaded area? We will subtract the area of these two triangles, which are basically congruent, they have same area. We will subtract the area of these two triangles from this sector's area to get this shaded area. Area of triangle OAC is equal to, I am using sine law, 1 by 2 into 10 into 10 into 36. This is the angle 36. Sine 36. This will be sine 36 degree. With the help of calculator, you can calculate this area, which is basically, now the shaded area will be area of the sector 62.83 centimeter square minus 2 times this area 50 into sine 36. This will be 62.83 minus 58.779, which will be approximately equal to 4.05 centimeter square, which is basically the shaded area, 4.05 centimeter square. Last part of today's class, D is point on the arc AB. This is D. Angle AOD ratio angle DOB is 1:2. It means we will divide this 72 in 1:2. This will be 36, this 24, and this will be 48 degree. Uh, Gavin says that shaded area on this diagram is same as the shaded area calculated in the previous part. We have to check whether he is correct or not. So what is area of sector? We calculated in the previous part 62.83. How we will calculate this shaded area? We will subtract the area of these two triangles from this to get this shaded area. So what will be the area of triangle OAB? Area of triangle OAB is equal to 1 by 2, 10 into 10 into sine 24 degree. This is 24, which will be 20.33. And area of triangle DOB is equal to 1 by 2 into 10 into 10 into sine 48 degree. Your calculator will give this 37.1572, and shaded area will be 62.83, area of this whole sector, minus 20.33 minus 37.1572, which will be 5.338. This is shaded area in this diagram, and shaded area in the previous shape was 4.05, which is different. So we conclude that given statement is wrong. Dear student, this is all for today's class. In next lesson, inshallah, we will further solve some past year exams question from this topic, mensuration. Please do subscribe this channel, share it with your friends. Stay tuned. Allah Hafiz.